Block 1. Cosmic Law Theory. Imagine a truth so fundamental it underpins every law of physics we've ever discovered. A single, elegant principle that dictates the waltz of galaxies, the frenetic dance of subatomic particles, and the silent, inexorable march of time itself. For centuries, this has been the holy grail of science, a theory of everything. But what if this ultimate law wasn't just a complex set of equations? What if it was something more profound, something that connected the cosmos in a way we never dared to imagine? And what if the person who discovered it wasn't celebrated but silenced? This is the story of Dr. Ilara Vance and her forbidden discovery, the theory of causal entanglement. To understand the seismic shockwave her work sent through the scientific world, we must first understand the woman herself. Dr. Vance was not a typical physicist. While her peers were focused on smashing particles together or gazing at distant stars through conventional lenses, Ilara was a pattern seeker. She possessed a rare, almost intuitive ability to see connections where others saw only chaos. She spent her early career in the less glamorous corners of cosmology, meticulously analyzing vast datasets of cosmic microwave background radiation, the faint, residual echo of the Big Bang. To most, this was just cosmic noise, a static-filled snapshot of the universe in its infancy. To Ilara, it was a symphony, and she was convinced she could hear a hidden melody beneath the noise. She believed that the universe wasn't just a collection of random events governed by cold, impersonal laws. She felt it was a single, coherent system, a vast, interconnected entity where every part was intrinsically linked to every other part, not just by gravity or electromagnetism, but by something far deeper: causality itself. This conviction led to the birth of her life's work. The theory of causal entanglement posits that the most fundamental constituent of the universe is not matter or energy, but, specifically, the information of a cause and effect relationship. In Vance's model, every event, from a star going supernova to an electron changing its spin state, creates a causal ripple. This ripple isn't a physical wave, but an informational one that propagates through the very fabric of space-time. Here is the revolutionary and controversial part. These ripples don't just fade away. They interfere, they resonate, and they collectively weave a complex, universe-spanning web of influence. Vance called this the causal matrix. According to her, nothing is truly isolated. The flap of a butterfly's wings doesn't just hypothetically cause a hurricane. Its causal information becomes a permanent thread in this universal tapestry, subtly influencing the probabilistic outcomes of countless future events across the cosmos. Her theory provided a breathtakingly elegant, albeit terrifying, bridge between the two great pillars of modern physics: general relativity and quantum mechanics. For decades, these two theories have refused to cooperate. Relativity describes the large-scale universe of planets and galaxies as a smooth, predictable system, while quantum mechanics describes the small-scale world of atoms and particles as a bizarre realm of probabilities and uncertainties. Vance's theory unified them by suggesting they are two different perspectives of the same underlying process. On the grand cosmic scale, the causal matrix is so dense with overlapping ripples that it behaves predictably, giving us the smooth space-time of Einstein's relativity. But at the quantum level, where events are few and far between, we are witnessing the raw, probabilistic nature of individual causal ripples. The famous quantum spookiness, the idea that observing a particle here can instantly affect another one over there, was, in Vance's view, not spooky at all. It was a direct observation of two particles following the same primary thread within the universal web of influence. The journey to this conclusion was arduous. Vance developed an entirely new branch of mathematics she called infodynamics. She spent years in isolation, running simulations on supercomputers, testing her models against known cosmological data. And slowly, patterns began to emerge. Her theory predicted with startling accuracy anomalies in galactic rotation that are currently attributed to dark matter. In her model, there was no mysterious, invisible matter. Instead, the outer stars of a galaxy were being causally tethered to the galactic center by the cumulative informational weight of billions of years of stellar evolution. Her equations also offered a potential explanation for dark energy, suggesting the expansion of the universe isn't being pushed by a mysterious force, but is rather a fundamental property of the causal matrix itself, which naturally seeks to expand to accommodate an ever-increasing amount of causal information. She had, on paper, solved the two biggest mysteries in cosmology with a single unifying law. This was her magnum opus, the culmination of a lifetime spent listening to the universe's secret song. Convinced she stood on the precipice of the greatest revolution in human thought, she prepared to share her findings, unaware that she wasn't about to be celebrated as the next Einstein, but branded as a heretic.
Block 2. Scientific Outcast. The stage was set at the prestigious Global Symposium of Theoretical Physics, an arena where reputations are forged in the crucible of peer review and intellectual combat. This was the moment Dr. Ilara Vance had worked toward her entire life. She stood at the podium, a lone figure of quiet intensity, facing a sea of the world's most brilliant minds, Nobel laureates, tenured professors, the high priests of modern science. The air in the grand lecture hall was thick with a mixture of anticipation and deep-seated skepticism. Her paper, The Principle of Causal Entanglement, an informational basis for a unified reality, had already sent ripples of controversy through the community before she even spoke a word. It was audacious, unconventional, and it lacked the familiar mathematical language of string theory or quantum loop gravity that dominated the field. She began her presentation not with equations, but with a simple, profound question. What if the universe is not a thing, but a story? She laid out her decade of research with methodical clarity, showing how her theory of the causal matrix elegantly resolved the paradoxes between the macro and micro worlds. She presented her simulations that mapped galactic rotation without the need for dark matter, and her models that accounted for cosmic acceleration without dark energy. She showed how quantum entanglement was no longer a paradox, but a predictable feature of an information-centric cosmos. For a moment, a hush fell over the audience. The sheer scope of her vision was undeniable. She was proposing a paradigm shift of Copernican proportions, asking them to abandon the comfortable notion of a mechanical, random universe for one that was holistic, interconnected, and woven from the very fabric of cause and effect. Then the questions began. They started as professional inquiries, probing for weaknesses in her methodology, but the tone quickly shifted. Her reliance on infodynamics, a mathematical framework of her own invention, was a major point of contention. It was unfamiliar, unvetted. They accused her of creating a system that was unfalsifiable, a circular logic that couldn't be tested by conventional means. The real hostility, however, ignited when the philosophical implications of her theory became clear. If every event was informationally linked, what did that say about free will? If the universe was a single coherent system, did that imply a form of consciousness or intent? These were not questions of physics, they were questions of metaphysics, and she had dared to bring them into the temple of empirical science. The attack was led by Professor Alastair Finch, a titan of the field whose own life's work was built upon the standard cosmological model. He stood, his voice dripping with condescension, and publicly dismantled her presentation. He labeled her work poetic speculation, not science. He derided her causal matrix as a digital ghost in the machine, a mystical concept masquerading as physics. The most damning accusation he leveled was that her theory was a regression, a step back toward a pre-scientific teleological worldview where the universe had inherent purpose. He called it a dangerous threat to the intellectual integrity of the last 400 years of scientific progress. The room, which had held a tense silence, erupted into murmurs of agreement. The fallout was swift and brutal. It was a character assassination disguised as peer review. Her presentation was officially struck from the symposium's records. Journals that had once courted her now refused to even review her submissions. Her university, under pressure from funding bodies and its own prestigious physics department, launched an internal review of her work. It was a sham. They revoked her tenure, citing a departure from established scientific methodologies. Her lab was shut down, her access to cosmological data arrays was cut off, and her graduate students were quietly reassigned to other professors. In the space of a few months, Dr. Ilara Vance went from being a respected, if eccentric, cosmologist to a pariah. She was banned from the very halls of scientific discourse. The personal toll was immense. She was ostracized by colleagues who had once been friends. The intellectual isolation was suffocating. For a scientist, the inability to publish, to debate, to have one's ideas challenged and tested is a kind of death. She was trapped in an echo chamber of one. Yet, through this professional exile, her conviction didn't waver. If anything, the ferocity of the backlash solidified her belief that she had touched upon a truth so profound, so disruptive, that the establishment's only recourse was to bury it. They hadn't just disagreed with her theory, they had been afraid of it. They feared the Pandora's box it would open. And so, the woman who claimed to have discovered the universe's most fundamental law became a ghost. Her name a cautionary tale whispered to graduate students who dared to think too far outside the box. Her groundbreaking theory relegated to the dustbin of forbidden ideas.
Block 3. Forbidden Truth. Impact. Years passed. The scientific world moved on, and the name Dr. Ilara Vance faded into obscurity, a footnote in a forgotten controversy. The establishment had successfully memory-holed her and her theory of causal entanglement. Yet, a truth once spoken can never be entirely erased. It lingers. In the quiet corners of the internet, on fringe science forums, and among independent researchers, her self-published papers began to circulate. A small, dedicated following of thinkers, disillusioned with the dogmas of mainstream science, began to seriously engage with her work. They weren't credentialed physicists from prestigious universities, but they were passionate, open-minded, and they saw the profound beauty in what Vance was proposing. They continued to run her simulations, refining her models with new data, and a fascinating picture began to emerge. The most compelling aspect of Vance's legacy is how modern discoveries made long after her exile seem to resonate with her forbidden theory. When astronomers discovered fast radio bursts, incredibly powerful millisecond-long bursts of radio waves from deep space, they were baffled. Yet, Vance's models had predicted that when a sufficiently massive causal thread in the causal matrix snaps or reconfigures, such as when a black hole evaporates, it would release a massive burst of pure informational energy that would look exactly like a fast radio burst. Then there's the growing crisis in cosmology known as the Hubble tension, where different methods of measuring the universe's expansion rate are giving conflicting results.
Proponents of Vance's work argue this isn't a measurement error. It's proof that the expansion isn't uniform. It's dictated by the non-uniform density of the causal matrix, meaning the universe is expanding in a more organic, complex way than our simple models allow. These correlations are, of course, dismissed as coincidence by the mainstream, but for those who study her work, it feels like a slow, inexorable vindication. Beyond these potential scientific validations, the philosophical implications of causal entanglement are what truly challenge our place in the cosmos. If Vance is right, our concept of individuality is a profound illusion. We are not isolated beings living the universe. We are nodes of consciousness, a universal information processing system. Every choice we make, every thought we have, is not an isolated event, but a new thread woven into the causal matrix, subtly influencing the entire cosmic pattern. This doesn't necessarily negate free will, but it recasts it. Our choices are our own, but their consequences are universal and eternal. It suggests a universe imbued with a kind of memory where nothing is ever truly lost. It implies a reality that is fundamentally interconnected, meaningful, and participatory. This is a far cry from the cold, random, and ultimately meaningless universe often presented by modern science. This resistance to a paradigm shift is not a new story. History is littered with figures who were ostracized for ideas that are now accepted as fact. Galileo was condemned for suggesting the Earth revolved around the Sun, challenging the Church's geocentric model. Alfred Wegener was ridiculed for his theory of continental drift, which is now the foundation of geology. Ignaz Semmelweis was driven to madness by a medical establishment that refused to believe his germ theory and the simple life-saving act of washing one's hands. In every case, the establishment wasn't just protecting scientific integrity, it was protecting its own authority, its own worldview from a disruptive and uncomfortable truth. The backlash against Ilara Vance can be seen as another chapter in this long, painful history of the evolution of human knowledge. Her story forces us to ask a difficult question. Is the purpose of the scientific establishment to seek ultimate truth no matter where it leads? Or is it to maintain the stability of the current paradigm? In the end, we are left standing at a crossroads. Was Dr. Ilara Vance a misguided genius who created a beautiful but untestable fantasy? Was the scientific community right to excommunicate her, to protect the rigorous empirical method that has served humanity so well? Or was she a true visionary, a pioneer who glimpsed the next great leap in our understanding of reality, only to be silenced by those too invested in the old ways of thinking? Her forbidden law remains a ghost in the machine of science, a tantalizing what-if that challenges the very foundation of everything we think we know. It asks us to consider that perhaps the most profound truths about the universe are not found in smashing atoms, but in understanding the silent, invisible connections that bind us all. This is a far cry from the cold, random, and ultimately meaningless universe often presented by modern science. This resistance to a paradigm shift is not a new story. History is littered with figures who were ostracized for ideas that are now accepted as fact. Galileo was condemned for suggesting the Earth revolved around the Sun, challenging the Church's geocentric model. Alfred Wegener was ridiculed for his theory of continental drift, which is now the foundation of geology. Ignaz Semmelweis was driven to madness by a medical establishment that refused to believe his germ theory and the simple life-saving act of washing one's hands. In every case, the establishment wasn't just protecting scientific integrity, it was protecting its own authority, its own worldview from a disruptive and uncomfortable truth. The backlash against Ilara Vance can be seen as another chapter in this long, painful history of the evolution of human knowledge. Her story forces us to ask a difficult question. Is the purpose of the scientific establishment to seek ultimate truth no matter where it leads? Or is it to maintain the stability of the current paradigm? In the end, we are left standing at a crossroads. Was Dr. Ilara Vance a misguided genius who created a beautiful but untestable fantasy? Was the scientific community right to excommunicate her, to protect the rigorous empirical method that has served humanity so well? Or was she a true visionary, a pioneer who glimpsed the next great leap in our understanding of reality, only to be silenced by those too invested in the old ways of thinking? Her forbidden law remains a ghost in the machine of science, a tantalizing what-if that challenges the very foundation of everything we think we know. It asks us to consider that perhaps the most profound truths about the universe are not found in smashing atoms, but in understanding the silent, invisible connections that bind us all.